All right, guys, welcome to another KevCAM night class tonight. I have Scott Harding helping out, answer questions and concerns and anything else that pops up. Scott, are you with us?
I am. Thanks, Kev. Yeah, we appreciate everyone taking the time to join us here on KevCAM tonight. Just if you have any questions, pop them into the questions dialogue, and I will stop Kev on what he's doing and let him know what the question is, and we'll get it answered for you.
Yeah, absolutely. Yeah, thanks for that, Scott. Yeah, for those of you guys that are new, the KevCAM night classes are, and apologize for our repeats in here, but the night classes are solely dedicated for you guys. It's all machining based and SolidCAM based, but you know it's kind of all off of your guys' ideas. So you guys just tell me what you guys want to see, and we'll teach it for you. So I guess with that being said, if you guys send your topics over to me via email, we'll get them added in there, and we'll either do a whole night class on it, or we'll do just a quick little YouTube video on it on how to do what you're looking for there. Let me put for those of you guys who don't have my email address, let me put this in here for you guys. So there is my email address right there, so you guys can shoot me an email. And then let me put in the YouTube channel here, and right here is our YouTube channel that I kind of started. It's been going about a year now. I think we've been doing the KevCAM night classes for about a year now, and hopefully everybody's enjoying them, but and getting something off of them. But if you guys want, you guys can come here. Have tons of videos in here on how to do everything inside the software, which is real nice. We got some live cuts in there, all the way down to product reviews. And pretty much on how to do everything inside SolidCAM, and we'll be adding to that tonight. So each KevCAM class is recorded, so you guys can come back and reference it, and also for everybody that can't watch it at 8 o'clock Central Time or 9 o'clock Eastern Time or whatever time zone you guys are in, but definitely come here, check it out, and let me know if you guys have any ideas or anything you guys want to see in there, and we'll get that off to you. So. All right, so with that being said, tonight we are covering parallel to curves under 5 axis here. And so this strategy enables you to perform the machining along a lead curve, and you guys can pick that lead curve, you guys can sketch it in there, you guys can use the curve that's already there. It's totally up to you guys on how you guys want to use it. Now, I did find something out real interesting when we're kind of going through the setup of these parts. Before, you guys were not able to do a transform with either 5-axis or HSS. Now we have the ability to do that, and I'm going to show you that in one of not our next part here, but it was really odd because I kind of came across it as my one computer had it and the other didn't, running the same version. For those of you guys that are looking to get this, and it's not on right now, and I'm currently running Service Pack 3 Hotfix 3, but if you guys aren't able to do that, let me know and I will get you, there's a registry key that we have to add in there, and I will get that registry key for you and show you guys. And actually, if you guys just give me, I don't have my escape up right now. Yeah, so with that being said, I'll show you how the transform works inside the HSS. And if you guys don't have it, please let me know. So, all right. So right here, this is actually the 4x4 lockout hub off of the older F-150s. I got this part from, or Greg got this part, and I guess for back in the day, the Fords had a plastic one, and now they have this is a replacement, is a metal one. So, all right, so what we'll do first is let's just do our 3D Imachining. And I'm just leave it on 3D General here. I'm gonna grab my tool, and we'll use tool number 1 here. And we'll just leave it at that. Let's just do a quick save and calculate here. And we got our toolpath in there. The only thing I want to change is my scallop height. So if I go to technology, and instead of doing scallop, I'm going to do a constant of, let's just do 40 thou. Oops. Save and calculate. And I know this is just a little bit of a refresh of 3D Imachining here, but kind of want to take you guys from the start to finish on these parts here. Okay, so let's do a solid verify. All right, so we have that completely roughed out, and you'll see that I left 15 thou on the wall and the floor. So now we can come back and do our 5-axis parallel to the curve. So real easy to use. Pretty close to the same thing as what we went over last week here, but just go ahead and grab your parallel to the curve. Now my geometry is, whoop, let me get rid of my toolpath there. So my geometry is going to be all this top surface right here. I can click all the way around that, but I got it ready here for us. Now the inside geometry that I want to use is the inside of the curve. And I think, I got this one. So let me just do a show real quick. And basically just grabbing that inside curve geometry going all the way around. So you'll see kind of going around the parallel and then kind of coming back up there. Now, what I want to do for this one is I just want to do somewhat like a trimming pass, but just want to do one cut. I don't care to do multiple step downs or step overs, anything like that. So I can come over here, just like HSS, and I'm going to do determined by number of cuts, and we'll leave that at 1. We'll go ahead and grab our tool number 2 here, and go to our levels here, and I'm going to switch this to plane to cylinder. And my cylinder, let's just go 2 inches. Toolpath parameters, nothing I really need to change in here at all. My step over really doesn't matter right now just because we're just doing one cut. So let's get over to the tool axis control. So I'm going to leave it tilted relative to cutting condition. I'm going to leave the lag angle at 0, but I want to use the side of my cutter when I go to use that. So I'm going to tip this over at 90 degrees.
Kev, I just want to interrupt 1 second. Ronnie asked, why no outside curve?
Oh, you can do inside or outside, Ronnie. It wouldn't matter on this one. So now, actually, maybe if we did the outside, my tool wouldn't be going as deep. So right now, when we go to throw toolpath on here, it's going to come up to that line. I can't. We may try that, Ronnie. Okay, so let's do orthogonal to each position, and let's just do a save and calculate. And you can see that I'm coming in there, the side of the cutter, and we're going in and dropping in and going around. Now, if I wanted to, I can reverse the direction. If I wanted to start over here, I can easily do that. But let me just show you something here. Let's just do a solid verify for a second. You'll see that I'm not getting in deep enough here. You'll see I got a little bit of a material kind of going all the way around. And Ronnie, I think this is why you don't want to do the inside versus outside, but like I said, we can double check this here. But I got that little bit extra material. Same thing as HSS like before. So what we can do is come to our toolpath parameters, and under, what am I looking for here? Advanced right here. And then I can put a negative value in there of, like minus 0.2, for instance. So now you'll see that we're actually going much deeper inside there. And, I probably didn't even need to go 200 thou. That's quite a bit. Let's just go 0, 50 thou. And now you can see that we're going much deeper in there. And get a straight down view for you guys here. You can see our toolpath is down in there. And just by modifying your shift for that toolpath. So if we do a simulation now, I'll slow it down here. You'll see that our cutter is definitely overlapping. Now we don't have to worry about not getting engaged deep enough with that material. Now, like I said, if I wanted to and switch that around so I'm starting on the opposite end, we'll just play through here. And now, basically what I'm telling it to do is stay, 90 degrees to that cutting direction at each position as it's going around that surface using a side tilt angle of 90 degrees. So I guess let me just kind of play this through here again. So what I'm saying is we want the ball, get a good zoom down shot here. So this bottom portion of the ball be 90 degrees to that surface, but also we're kicking the cutter over at 90 degrees also to the coordinate system, I guess you could say. So hopefully that kind of makes sense for you guys. Let's do a machine sim real quick. Okay, so we're rotated around here, and let me just slow it down just a little bit here. You can kind of see exactly what's going on here. And you'll see the trunnion rocked back and forth to accommodate that orthogonal to that surface. You should see it do it again right here. Very small little bit, and then comes right back up. So, and like I said, if I wanted to, I can come in here and under the regular toolpath parameters here, flip my step over, excuse me. So if I do save and calculate now, it's still starting at the same spot. Turn it off from zigzag to one way. So now we're starting out over here. Now if I do the flip, it will start on the opposite side. And it's not. Okay, I gotta see what's going on here. Got one way. Okay, that will flip it over. Not sure what I'm missing here.
Ronnie says that you didn't check the box.
Maybe if I just uncheck it. Okay, so let's save and calculate here. Okay, uncheck the flip. Huh. Well, that should be doing it. Trying to think what else I'm missing here. Should be on one way.
Cut order, Ronnie says.
Yeah, but I did, let's try that. No, I cannot get that thing to flip over for us. Well, I'll have to look into that. Why it's not flipping for us. Okay, so now, can I get off topic here now? So let's take and what Ronnie was saying before about the geometry. If we go to our edge curve, and instead of picking the outside or the inside, we'll pick the outside. And should grab us going down. Get kind of rotated around here. Oop, undo. And we'll flip the one up. Yep. So it's throwing that line on the outside versus the inside. So that kind of determines your levels a little bit. And like I said, we can accommodate that by going into our tool axis control under the advanced and making that number more of that. But yeah, so I guess kind of depends on where you click it on the levels for that particular one. So each surface is going to be different for you guys. I really wish I could say no matter what, it's going to always do this with any surface you run across, but since we are working on the actual SolidWorks file itself on the surface NURB, it's really unknown on what that surface, how it was built, how everything was merged together, all that stuff. So, okay. Any questions on this part right here? And let me just switch this back here. I'm still completely baffled on why my flip over is not working, but so if we go to Machine Sim, get everything loaded up here. If you want to see the whole housing, you can kind of zoom in there and play her through. And we're done. So, okay. So kind of starting off with a little simplified part there. Like I said, any questions with this particular one right here? All right. So let's get into another one here. Now I know last week we had some issues with screen not refreshing as fast as it was. Are you guys able to see everything go through pretty fluently? I know last week we had a huge storm rolling. I don't know if that's what did it, but seems fine. Okay.
Yeah, everything looks good on my end, Kev. Yeah, again, yeah, everyone's saying that the refresh rate looks much better this week.
Perfect, perfect, good deal. Okay. So I apologize for that last week. I'm not, like I said, we had a huge storm come through. It was hailing and everything, and I don't know if that affected it or what, but okay. So let's get going on this part right here. So I kind of turned it down already here, and now let's get into the 5-axis. So for this particular one right here, I'm just going to grab contour, kind of show it here, milling out. Get my part flipped around here. Milling out that triangle right there. And let's grab our tool here. Levels, I'll just say 150 thou deep. And we can do step downs of 75 thou. And the only other thing I want to do is throw a wall offset of 5 thou in there, so I can come back and use that 5-axis and get the head to rotate and follow that surface the way I'm looking for here. Let's just do save and calculate. And it looks exactly what we're looking for here. So I'm going to do a quick transform and include the original. Since we have 3 of them, it's 120 degrees. Okay, so we got those pockets all machined out there. Simple, easy, kind of refresh there. Let's go ahead and do another pocket here. And I'm going to grab position 2 for this one. And I'm going to grab my contour 11, show you guys that. So just doing this pocket right here. Here, let me get this toolpath turned off for you guys. So we're just machining out this pocket as an open edge. Grab that same tool number 2 there. And let's see, we can just go, let's see, 300 thou deep. to get everything there. And technology, I'm going to leave that same 5 thou on the wall. And let's just do a save and calculate. Looks good there. The only thing, I'm not starting from the outside. So let me go to open pocket, approach from outside. Beautiful. Okay, so let's transform that again. All right, so it looks like we're cutting everything that we need to there. And let's just simulate just to get a verification on it. So we got our triangles cut out there. Okay, so we got those pockets cut out now. Okay, so now let's get into the 5-axis portion here. Do our 5-axis, turn off that toolpath here, and we'll do our parallel to curve. And I'm gonna grab, let's see what I got here. Yeah, that'll work to get that outside. And I gotta find my contour that I'm looking for here. There we go. Going around that outside perimeter here. And like what we did before, I'm gonna do determine by number of cuts. Go ahead and grab our tool number 2 here. And switch this over to cylinder. 1.25, oops. Does anybody know what this part looks like? It's actually supposed to be a hole saw. And okay, let's go to toolpath parameters. Nothing I should really have to do right here. So now I'm going to leave it on default, tilted to relative cutting condition. Same thing as what we kind of just went over with that 4x4 hub. Then I want to lay it on the side. So I'm going to do 90 degrees. And we'll do orthogonal to each position. Let's just do a save and calculate. And let's go ahead and do a simulate here. And I need to go deeper. I'm not getting deep enough in there. So we'll go to advanced, let's just do a 50 thou. See that dropped our toolpath down inside there. And let's just try a machine sim for this one here. Trying to get different machine sims for you guys here. And let's go ahead and play this through. Hang on one second. This ran into this last week. What I forgot to do last week when that head was rotated all the way around, if you guys go to your machine controls, turn on the rotation limits. Get everything loaded up here. And let's play this through. Zoom out for you guys a little bit to see it. All right. All right, looks good. So telling it to stay 90 degrees to that surface. Kind of wish they would just change the wording on this orthogonal. I really don't like that, but just like 90 degrees to cutting direction at each position. Okay, so let's do another 5-axis one, and do a parallel to the curve again. And now, so grabbed, nope, there we go. So I'm going to be doing that, our inside triangle now. Edge curve, let's follow the curve of that. And gotta find my triangle one here. There we go. And like we were talking before, you see that pick the bottom versus the top, and that's just to accommodate that Z depth. So now I'll do determined by number of cuts. Go ahead and grab that, the tool number 6 here. Levels, you know, I can actually leave it on plane since we're going to do a 4-axis transform on this one. So I'm just going to leave that for right now. Toolpath parameters. One thing I'm going to do in here is I'm going to come into the corner rounder or the round corners here and just put a 2 thou in there. Let's change it up a little bit here. And the only other thing that I need to do that I got to change my side tilt angle to 90 degrees again, and I know I'm going to need to go past again, so I'm going to do that minus 50 thou and save and calculate. So we're coming in there, buzzing around the outside of that using the 90 degrees to that surface. Let's just do a simulate here, get a sanity check. And I'm going to slow this down here. And it's really hard with the Solid Verify to actually see what's actually going on. I mean, we just see the tool kind of buzzing around, but I really like to bring that machine sim in there and really see what that head is doing. All right, let's play this through here. And you can kind of see a little bit of the head rocking back and forth a little bit. Okay, so that's exactly what we're looking for. So, like I was mentioning before, HSS has the transform feature now. Now, I know a lot of you guys aren't sitting at your desk right now, but if you guys don't have this, let me know. And let me see if I just still have it in my edit here. So what I had to do is I had to add this key in here, 5-axis transform enabled. This is going to enable your HSS and your 5-axis. It has to be this file format exactly, case sensitive and everything. Like I said, I downloaded on the one computer, it had it, and this computer didn't have it, so I had to add it in there. So if you guys don't have that capability, let me know and I can copy and paste this key out, or if I want, I'll copy and put it in the chat log for you guys. And this is going to be a D word 32-bit. And for those of you guys that are unsure about the registry, if you guys come to this location, so computer HKey current user, software, SolidCAM 2016, and CAM experimental mode, right click and say new D word 32-bit value, and then you can put the name in there. So, and if you guys aren't comfortable doing that, definitely give us a call on the support desk and we will add this in there for you, because if you guys come in here, if you know too much about computers and mess up something, you know, at the level here, accidentally delete this, you just turn your computer into nothing, a paperweight. So definitely let us know if you do have questions on that. So, okay, we'll get into the, oh, go ahead, Scott.
No. I was just agreeing with you that, and I was getting ready to say the same thing. Just call us at the support desk if they're not comfortable with that. I've messed my registry up before, thinking I knew more than I did. You know. So.
Yeah, you can definitely get yourself into a lot of trouble real quick in that registry. So, but now you'll see I have the capability to do a transform, which is really cool. So do a save, and now let's go ahead and do a simulate here. Get kind of zoomed in on our machine. Maybe we can speed it up a little bit for you guys. And so now, when you guys are running a part, you know, since you have similar geometry, definitely take advantage of that that transform. If you guys wouldn't have that excuse me, before, what you'd have to do is we could try doing it all in one operation, but I would definitely recommend breaking it out. And same thing with HSS. You guys are working on, you know, a surface over here, and then on a different side of the part, you're working on a different surface. You can do those together. You may have to do a little bit more tweaking, but it makes life a lot easier if you guys just separate them out. So, okay. So now let's go ahead and do some trimming, or the chamfer. Do our 5-axis here, parallel to curve. And I always forget to shut that toolpath off. And chamfer that that triangle that we cut out. And our curve is going to be, I think it's our top one here. Yep, contour. And we'll do determined by number of cuts. I think we'll use a ball end mill for this one here. And levels, we can leave it on plane, like I said, because we're doing a 4-axis transform here. So toolpath parameters, since we're doing determined by number of cuts, really doesn't matter. Tool axis control. So right now what I'm going to do is I'm going to leave these at 0. So the tip of that ball is working on that surface. But what I'm going to do is I'm going to tell it to follow the ISO line direction. So follow along the direction of that contour going all the way through. So now let's just do a save and calculate here. Kind of coming in there. And I already see a problem here, but let's just go to the machine sim. Okay, so let's go ahead and play this through slow here. And right there, I don't have my crashing enabled right now, but if we restart that here, you'll see that my head actually, let me get rid of the right there. If I would have had my crash detection turned on, that would have showed up a red for you guys. So what can we do to fix that? A couple different things, but we can come to our angle range, and I can just limit my angle. So right now, I'm going from my B axis from 0 to 360. So if I limit this down to, I mean, just even 180 degrees. So you can calculate here, simulate. Let's get in here again. So now it's going to rotate 180 degrees. It's not going to go the full 360 degrees. So when it gets to do that backside, I'm kind of locking it down, keeping it from the head kind of going into the spindle there. So a real nice feature in there. So now that I have my one done, let's just, like I said, instead of chaining all those, let's just do a 4-axis and do our same 120, insert my other 2 steps. And let's play this bad boy through. So like I say, following those ISO lines, it wants to rotate that head around, but like I said, we're locking it down so it can't. But leaving a nice chamfer kind of going, or like a trim going all the way around the outside edge of that part. If I need to go a little bit deeper, we could go to that advanced tab and you know, do a negative value like I was showing you guys before here. But Okay, so now,
Kev,
yep.
Ronnie asked to please show the limit box again.
Oh, right here. So right in your tool axis control, angle range right here, and I'm limiting my B axis so it doesn't rotate. Now it's going to be all depend on where, what axis you guys want to lock down. So right now I told my B only 0 to 180, but my A axis can go 360 degrees, and if I had a C and a W, those could also go out. So that's where she is, Ronnie. Okay. Now, the only thing I have left to do is my outside perimeter, going all the way around the outside of the part here, doing that same chamfer. So this one I really don't need to do a transform because I want to go all the way around the outside too. So let's just go to geometry, and I think that's the one I'm looking for. There we go. And same thing, determined by number of cuts here. Grab that same end mill. Levels, now I'm going to want to switch this over to cylinder here to go for that, but yeah, let's run to cylinder. Toolpath parameters, really not going to worry about what's going on there. Now what I'm going to do is I'm going to tell it to stay 0 and following the ISO lines like what we said before here, and I'm going to limit my angle to that 180 degrees of movement, and we should be good. So let's minimize this for a second. You can see coming in there, moving all the way around, going around that outside edge, all the way around, getting that that trim or that chamfer put on there. Let's go ahead and do a simulate here. Zoomed out a little bit there. There we go. Did that go too fast for you guys? Slow it down just a little bit here. So just following that outside chamfer, working right on just the tip of that cutter. And basically kind of using it as like a deburring. All right. Any questions on this part here before we jump to our next one? Okay, looks like we're good. All right. So let's go ahead and move to our next part here, our last part for the night. And so this is a little bit of a simplified one here. Basically the only thing that we, that are doing 5-axis on here is the this outside perimeter that's going on right here. So pretty much along the same lines that we've been kind of going throughout the night. And like I said, with this 5-axis and the head tilt, the lead and lag and all that stuff, pretty much the default values are pretty good for the most part. And like I said, you guys are going to come across some other ones in there that you may have to use. I'm trying to show you guys as much as I can and get different parts to show different features that we can use in there, but for the most part it's pretty simple. Okay, so we got that outside perimeter, looks good. And chaining the outside, or the inside I guess you would call it, and this is just to accommodate, so the tool will go down to this point right here. Obviously I'm going to want to go just a little bit deeper past, so I'm not working right on the tip. If we are, we're going to have a little bit of a edge kind of going all the way around. So grab that contour there. Determine the number of cuts again. So we'll just do one single cut going all the way around. Grab my one and only tool. Toolpath parameters, really not going to worry about it here much. Tool axis control, kind of leave it defaulted right here, but I want to work on the side of the cutter. I don't want to work on the bottom flat. So I'm going to kick this over to 90 degrees. And let's do a save and calculate. I'm going to do a machine sim on this one too. And let's go ahead and play this through. Keeping that tool 90 degrees to that surface the entire time. There we go. Now the only thing I forgot to do is on this part right here, probably want to bring my Z down a little bit to go a little bit past. And if we just do a solid verify, you can see that cutter is going, if I can catch it here, staying about 50 thou deeper than what we told it for that edge curve. Sorry, I'm trying to race it around here. Now if we want to, we can go ahead and hop over to Machine Sim. Play that one through again here. Get rid of our machine shroud here. Just like that. So any questions, guys, with the parallel to curve? That's pretty much about all I have for tonight for the parallel to curve. Like I said, kind of real interesting, you know, using that transform right there and really be able to simplify a lot of the operation, especially on that last part that we did there. So.
Yeah. Now, Ronnie asked if that's cutting into the part.
Oh, let's take a look here. It probably could be because I didn't even have a gouge turned on. Let's try it. Speed this up here. Yep, right here we're gouging in right here. So and let's guess on the other side too here. Yep, good catch, Ronnie. So let's go to our gouge check, enable. And now let's take a peek here. Looks like we're just, yeah, we're good because I got 4/10 tolerance here, and let me just see my accuracy. Yeah, we should be good. Let me check all the way around here. Yeah, so it looks like we're good there. That's because I know about the radius of the tool versus, yeah. Yeah, so what Ronnie's saying is pretty much the radius of the tool trying to get in here, going around, so you can definitely see a little bit of difference. And, you know, that's why I definitely use your solid verify in that stock target comparison, you know, and come in there and check all of it. Completely overlooked the gouge check on this particular one here, but you definitely, and especially with the 5-axis, you know, make sure you get your holder and arbor all turned on. So if you guys do get into a bind, you know, at least you're catching on the machine sim, 1, and then 2, you guys, kind of like with that part we did last week, where that entire holder and everything, doing a gouge check against that fin on the right-hand side. If you guys want, I can bring that part back up here.
And Kev, Ronnie wanted to know how much smaller tool do you use compared to the radius?
Oh, let me grab that part again here.
Yeah.
I guess I didn't even look at the radius diameter in there. So we got a radius, well, I got an arc length. I don't know about you guys, but I can't stand when it gives me an arc length. I just want a radius. So, and let's just grab tools. And we're using, let me close this, try to get this part. We're using quite a bit larger than what we're supposed to have here. So, so we have to, you know, it's definitely seen an issue there. But I guess I don't, to give you a 100% answer, I can't tell you, Ronnie, but let's just switch it over to a 0.25. And we'll do save and exit. Come in here. Save and calculate. And I'm going to just turn off that gouge and see if it still does it here.
Jeff mentioned that you can measure radii with the evaluate curvature tool.
I'm going to check that out. Yeah, we're still gouging in just a little bit, Ronnie, and I'm guessing because it's trying to get in that little pocket right there, so I'm not sure how much smaller we'd have to go with the tool, but let's check Jeff's comment here. Get over to the radius. So we get that. So we got arc length, and go to our evaluate, measure. All right. Curvature. What am I missing here? Where's
And now he says no curvature, so I guess it's not there. Or
Jeff, you may have me a little stumped here. I'm not sure what you mean by yes, the colored curvature button. Colored curvature button. Oh, right here. So,
and hover over a curve on the model, he says.
0.5? Is that what it's telling me? Yeah, it looks like it. Cool. I've never just tried that out. Thanks, Jeff. Learned something new tonight, and well, no. So I guess for those of you guys that, like myself, what I would normally do is come in here and draw a sketch with a circle, and so I could get an arc or my radius instead of getting an arc length. Go to your curvature tool and just hover over it, and it's going to give the radius of what you have there. So very cool. Thank you, Jeff. Yeah, that's cool. I never even played with that one. Guess that's what happens when you're self-taught. Okay, and I was just going to bring up the part from last week that we were doing. I was talking about, for those of you guys that didn't get to see it. So this one, doing that 5-axis, and we could do parallel to curve on this one too, but we just did parallel to surface. But using that gouge check against the holder and the arbor to make sure we're not whacking out that fin right here as it's going around. So just do a simulate here, machine sim. And we can definitely play this or speed this one up here. And you can kind of see it's kind of overlapping and avoiding with that holder and the that last fin. So yeah, see, Jeff, you're even teaching Clarence and some of our other guys that didn't even know that. Appreciate that. All right, so any other great tips or tricks there? You should have Jeff come in here. we got a bunch of people didn't even know about that curvature tool, so yeah. But no, I appreciate all the input from all of you guys. It's real nice to see that you guys are putting your feedback in there too, and keeping me up on my toes and showing me something new as we go too. So I really do appreciate that. And do we have any other questions regarding the parallel to curve? So next week we are going to be hopping into, what is next week? Multi-axis. So we will be doing parallel to surface. Now, I was kind of thinking about this yesterday, and we're doing parallel cuts, parallel to curve, parallel to surface, all this. Well, we already kind of covered what all this kind of does, more in a sense, when we were going over the HSS. And we'll still kind of go through it with 5-axis, but we'll try to find some more parts that kind of utilize more of, this bottom stuff here that you may not use on a day-to-day basis. So we'll still kind of follow along these lines here, but I'm not going to really solely base on, perpendicular curve, because like I said, we've already kind of covered it. I don't want to bore you guys and recover material that was there that we've already covered. And I know it's late at night, so I don't need you guys falling asleep on me, but I think if we kind of get in more to the depth of, using some of this stuff, and it's going to be tough, but if you guys do have parts that you guys would like to see the 5-axis done on, definitely send those over to me, and we can add those in there as long as you're okay with the whole world being able to see it. So, but and same thing down here, like I said, my go-to ones are always going to be follow ISO lines, orthogonal at each position, and orthogonal at each contour. But these ones down here I don't use hardly ever. So we'll try to get break me out of my habits there and start using some of those on some of these next parts coming up. But like I said, guys, if you guys have suggestions or ideas, definitely send those over to me. And can't thank you guys enough for joining the night class. Got quite a few people in here tonight, which is awesome. I love seeing that. A lot of new faces I see in here too, so which is also good. And for those guys that didn't catch right away at the beginning, we do have a YouTube channel, pull it up here, where this class is being recorded right now, so you guys can go back and review it, or any of the other night classes that we covered in the past, or live cuts, or any suggestions that you guys have thrown off to us. So there's about a year's worth of stuff in here for you guys and to check out. So, all right, guys. Scott, you got anything else?
Nope, that's it from my end, sir.
All right, guys. Well, thanks again for sitting through another night class, and appreciate it, and hopefully you guys got something out of it. I know I sure did by Jeff, so I really appreciate that, Jeff. And Ronnie for with the drive direction going deeper or shallower. But yeah, appreciate the time, guys, and look forward to seeing you guys next week. All right, guys, have a great day.
Thank you, everyone.
Bye-bye.